Okay, so now let's continue with the ground. So let's grab this, let's say, can we base off this floor object? Let's think about it. Just hide this. Let's think about this. So missile's gonna hit right in the center here. So what I'm gonna do, let's see what we have there. We have that floor. Let me hide this ground plane. Alright, so here we have this ground floor here, and I think we can use that for the yeah, I think that's enough area to destroy, because we want the destruction just to stay here in this area. We don't want cracks all over the place, so that wouldn't be realistic. So let's call this ground, and let's put it back here so we have a clean area to work. So actually we can make some cleanup here. We can put these guys here and made a group for that. Let's call this car, and we can leave that as gray. This is the missile, this is the reference stuff, so we can make a box for the missile. Not that one, that one. Call this missile, and that is not correct. Why did that happen? Just move this over here, call it missile. And we can maybe color this yellowish color, put it here, and this is camera reference and stuff, so we'll just call this reference for now. Leave it there. Color that purple, and let's save this version. 4. Let's start with the ground. Let's hide the car for now. Well, alright, let's leave the car there. So let's start with the ground. And what I'm gonna do with the ground is actually divide it, focusing the detail more where the missile is hitting. So let's go inside there and hide this. Don't need to see the camera for now. Just home this to have the default camera, and I want to get the cracks. Let's see where this is the point. Let's add a sphere to see exactly where the collision is gonna happen. So the sphere, I think it's kind of like there. The collision is gonna happen kind of in that area, right? Feels like the collision is in that area. Actually, you can move it back a little bit around there. So I'm gonna keep this as the reference, so where that is actually hitting, and I think I move it way too much. There you go. I think that's good enough. So I have that reference there as where that thing is hitting. So I think I changed the wire from color for this. Yeah, just remove that so it's not that green color anymore. So now let's start thinking how we can do this. So we can just go ahead and do like this grid. Of course it needs some depth, so let's do a poly extrude first and extrude it down like 0.1. Think about this. 0.1 is gonna be like 10 centimeters, so just keep that in mind. We're working with meters. So 10 down, just change this to average position so we don't have double points in some areas. And we want to add to the back so it's closed. Alright, so we can just, with this, we can just go, just go to the model and use the shatter tool here, and it will just shatter our plane there. So I can add more pieces here in the scatter sub, go to the Voronoi fracture and visualize the pieces. You can see I have those pieces, but the problem is that those pieces are just kind of randomly all over the grid. They're not focusing on this area, and I want smaller chunks here and going out to bigger chunks at the end, and at the outside just the biggest chunks that are not just gonna be, those bigger chunks at the edges are just not gonna be moving. So let's try to do that with the way we can do that. It's in the scatter sub. We can actually, let's see, we have those points are all over the place, but we can focus them in the center by using by painting the geometry. So that's what I'm going to do. I'm going to paint the geometry before I actually even extrude the geometry, and then I'm going to just paint a bit of color into the geometry to have that guide the points actually. So okay, let's do that. I'm gonna do, even before we fracture the, before we extrude and fracture that, I'm gonna go here, and I know that the I'm gonna actually subdivide this a little bit more because it's gonna be, I want more divisions for the paint to be better, more defined. So I'm gonna drop a paint sub, and that just, I'm gonna remove the color I have for the viewport, just make this white as it is, as by default. So if I have my brush there, if I press shift and drag, I can make that bigger. Now I'm painting white, but if I change this to red and start painting actually orange. So how to do this? Well, first I'm gonna flood everything with black. So just choose black and hit the button apply to all, and everything is black. So now I'm gonna change this back to white, and I'm gonna start painting white a little bit, and not too much. Let me change the opacity down like 0.3, start painting a little bit around, and with that, let's go and see what it does. So when I extrude that, it actually keeps that. And the other thing I want to do change here is actually I don't want this fog conversion here, because this is for it's used to scatter points on the volume, so the points are not just on the surface. But since this is a very small surface, I don't actually need to scatter points inside, so I'm just gonna get rid of that, actually just remove it altogether. So now here in the scatter sub here, I can change the alternate attribute here, alternate attribute property, to use the color, and you can see now the points actually jumped to the center. If I actually add more points, you can see what's happening. It's adding more points where we painted, and the rest of the points it's out. So if we don't want any points outside, we can just use this attribute bias here to say to this node we want us mesh points in the paint, and this the let's like say 0.9 or 90% of the points we want it to be on the paint area, and the other 10% is it's scattered all over the place. Like this is by default is 50-50 points. Like this is just all over the place. Ignore that. If we go all the way, all the points added to the painted area. So let's do here like around 300 points maybe. Let's see how that I don't know, 300 points is too much, maybe 60 points, because I'm gonna add more points on top of these points. So let's see how that looks now. If I go here and we just add a color sub here to remove the color. No, not a point color, not a color, actually a point top that says no color. So I'm just removing the color attribute from here so I can actually view the pieces here. So there we go. Now the pieces are smaller here in the area that we want, and start getting bigger and bigger at the end, which is now at the end is these huge pieces out in the outside. But now those pieces are too regular for me, so you can see they're kind of the same size, they're not as interesting, so we need to make them more interesting. And the way I do it is just going to the no, I don't want to see that because it's gonna be slow. The way I do it is I put you can see the points there. I can actually make the points bigger so you guys can see it well in the recording. Point marker size 5. That's huge points now. So what I do is it's just the point replicate top, which adds points on top of those points. You can see it kind of creates like a sphere of points in that in every point location. But 100 points for each point is too much. Remember, I had 60 points here plus that 60 plus 10. I only have 600 points now. And the other thing you can do here is add a little bit of change how the distribution of the points are. Now it's in box at the moment. Sphere might be better for you. You should just go and try different things, maybe make them not as big as spheres and something like that. I like to have like small chunks of stuff. And the other thing is I have like too much points on the outside. Maybe just put this up to 0.7, something like that. And you can change the random seed to find something you like there, like that. I don't like that. Something like that, maybe. Something maybe like that. Let's see from the camera. You can just tweak this to your taste. So okay, I got that so far. The other thing is you can add actually noise to these points. Well, you are actually adding noise to these little spheres that you are actually creating here. So I like to add a little bit of noise and make them more random. Still, you can see they're a little bit more random there. So I just kind of move those points to be to bunch together a little bit there. And what else would I want to do here? Do I want to keep the attributes? I don't have any attributes there, I think. So the other thing now that I have this, sometimes I even actually add another point not point generate, point replicate, and not have it as huge as that, like maybe lower than the other one, just to have more variation, and change the size of it. But just keep in mind how many points you are creating there. So something like that would work for me. And now if you go to the Voronoi fracture, you can see how awesome this is looking now. Go here, you can see we have a bunch of detail here where we want to, like the sphere. There's our sphere, there's the reference point. We have a bunch of detail here, a bunch of different sizes of pieces, and then it started to get big and bigger and bigger. But we also have these little parts that are actually smaller chunks. I like to have that because it gives you variation. If this breaks over to this side, there's not only big chunks but also smaller chunks there. And you can go to the chunk centers and change the random seed and see what you like. I like that a lot because I don't like that as much. Well, I like the other one better. You can go and say, alright, what is, I like that one because I have this area. This could be the parts that are gonna be racing from the floor, and I have a bunch of small pieces that is gonna be broken by the explosion of the missile. So yeah, I like this very much. I guess I'm gonna just lock into this version, just making sure it's the right direction that I'm looking at. Yeah, I like that one. Just make sure that it's on the place that you want your destruction to be in. And the other thing we're gonna do here is actually just I don't know if we should just add UVs now or later, but no, we're just gonna do that later because it's not that hard. Once you know what you're doing, it's not that hard. So we have this, and I'm gonna create a null here just to make sure that if I want to do something here, I'll do it in this null ground. So this is let's put the fracture ground, so I know this is the fracture ground that I want to use. And I think with this we're gonna go to, yeah, with this just hide that, and now we're gonna go to make this explode. Yeah, I like that a lot actually. Yeah, it's a pretty cool fracture pattern there. So let's do that in legal. I mean, let's take this. Oh, come on, take this into fracturing. Do a fracture dop. So first, before I'm gonna just hide that car and hide the missile. Before we even start, I'm gonna create a dop. A new dop network by hand, because I want this to be the current one. If you can see, let me just make Houdini smaller. If you saw my introduction to dynamics, which you should have, or you may already know this, there's a current simulation that it's being used for this, and that is the one that's gonna be receiving new geometry that you create from the shells and stuff. So I'm gonna create just a dop network by hand, and I'm gonna call it dop ground. and I'm gonna color it blue as before. I'm gonna hide that, and now I'm gonna go here and make that the default. Make that ground. It's the default one that the current one that we're using. So when I actually use the shelf, my object's gonna go to this top, not this one here. So yeah, I like to have my different parts into different DOPs if they are not gonna be like interacting with each other directly. So that keeps the overhead a little bit lower and keeps your scenes way cleaner. So with that fracture object selected, let's go to the rigid bodies shelf and select the RBD fracture. And for this, Houdini shows you this dialog. It's asks you what kind of fracture objects you want, and we're gonna use the new packed object primitives, which are actually pretty cool. And we are gonna see how we can control these guys, which are actually a bit different than the standard primitives, but way faster. So if we click play now, you can see that is actually being simulated. It's pretty slow because we have a ton of geometry, and you can see some parts are actually breaking because of the internal collisions they're having there. So let me just go to flat shaded, no wireframe. Okay, so go inside here and we're gonna create a ground plane. If you want to create it by hand, or if you want to just, since this is the current simulation, you can just click here and you're gonna have that there. Okay, so we're gonna be careful here because if we leave it there, our floor is actually under it. You can see our floor is down here. But be careful, because if we put this under the floor, it's gonna be exactly 0.1. If we do that, just be careful because the pieces that come from here are gonna come and gonna collide here, and then gonna collide here, which is under the floor. So just be careful. We're gonna add another surface later here so the pieces don't go under the floor, but or we can restrict the movement so to this plane we can just move them up by an expression or something. But I guess the easiest thing will be, we'll see if we use an expression or just a plane, another surface to collide with. So there it is, ground plane for the ground. And as before, I like to color these guys blue or cyan, so no, these guys are the simulated stuff. If I hit play now, nothing much is gonna happen because the floor is sitting on the ground plane, so it's not gonna move, it's not gonna happen, nothing's gonna happen. So as we did for that, let me just press L to arrange these guys. As we did before with the car, that we flip that with a magnet force, we're gonna do the same thing here with the floor. We're gonna create a sphere here, or magnet metal ball, and explode the pieces from there. So let's do that here. Again, same workflow. Because why? Because that workflow it's pretty damn cool. Don't forget to uncheck the use external sub if you are creating the geometry inside this node. Right now it's complaining that there's nothing inside there. Let's go inside there and create a metal ball. Make it, let's see, why is it still complaining? Just bypass it and enable it again. So is that in the right place? Maybe not. Maybe it's a little bit, we need to move it a little bit more next to be in the center of the destruction. You can actually go and display the missile to see where the missile is actually gonna be hitting at frame 16 again, but that is being simulated, so just be careful when you use craft like me, crazy me. And you can see that's actually kind of starting to work there. That is actually displacing the moving the pieces a little bit, and look at that, actually it's hitting the right place. Cool, I like that. It's hitting just in where it needs to hit. So let's go back to the top ground. I'm still gonna move that sphere a little bit over in X a little bit. Just go back to frame 1. Center on X. I want it around there. Yeah. And maybe a little bit back in Z. Alright. So let's go back. And in magnet force we wanted to repel the pieces, so let's put a negative force. I don't want to show this guide since I already have this geometry as the guide. If I hit play now, you can see now those pieces are actually flying away from that surface, and those pieces look pretty cool. They're actually displaying, I mean, the pieces look good for the shot. The sizes are good enough, I think. Yeah, those pieces are pretty cool. You can see it's starting to look pretty cool already. We just did that and it starts to look pretty damn cool. So let's just play with the force. Let's see how much force do we want. I might not want that an excessive force, and I like those pieces are coming towards the camera. That's pretty cool. Alright, I think that force is pretty cool. I like those pieces that are coming towards the camera. So, and also you can see this is simulating very quick, and we have a bunch of pieces. This should be a lot of pieces there. And as you can see, the pieces on the sides are not actually moving because the force is not reaching as far, but we are gonna make sure that those pieces are actually not simulated. So you can see that starts to look pretty cool. That was really easy to do, really easy. If you know what you want, if you fracture your geometry correctly, it's just very simple to do. Just once you know what the hell are you doing. But just be careful to see. You see that piece that ends up here, that one just goes from one level to the other, which will be a problem later. So just keep that in mind for later. Alright, we need to fix that before we cache this thing. But there's another thing we need to do here. If you remember in my simulation, there's these pieces here. We're actually not getting any. Let me just play this and say, so you see this area here, these pieces, these big pieces, I want it to be raised, like there's like a little volcano forming there. There's a crater there. The force from the inside the center got pushed out, and the dirt and stuff, get these things moving up. So I want these pieces to actually move up. But how do I do that with this force? How do I move those pieces, or what can I do? Well, what we're actually going to do is actually add another object and actually move that object from under the geometry and make those pieces collide with it, so that keeps the pieces in place. So it's all about cheating, guys. Let's just create a new geometry object. I can create it outside here, I can create it inside the top, but just choose your workflow. I'm gonna say this is gonna be the creator shape. I'll call it that. Go inside there, and I'm gonna create a sphere here, because a sphere, it's gonna give me what I want. I'm gonna unlock this, and this is my sphere. I'm gonna go for a polygon mesh sphere. Have more divisions. Make it, shape it to kind of the shape I want for this crater. We can even maybe deform this so the crater is not totally round. Not as much, but we can do something like that to make it. If you are not catching what I'm saying or don't understand what I'm gonna do with this, you will in a second. So I'm gonna put this under, and when I erase it, it's gonna erase these parts there. Those pieces there are gonna be lift up with this geometry, and they are gonna be forming like a crater shape there. So that's gonna be it. That's my geometry. How do I move those pieces, or what can I do? Well, what we're actually going to do is actually add another object and actually move that object from under the geometry and make those pieces collide with it, so that keeps the pieces in place. So it's all about cheating, guys. Let's just create a new geometry object. I can create it outside here, I can create it inside the top, but just choose your workflow. I'm gonna say this is gonna be the creator shape. I'll call it that. Go inside there, and I'm gonna create a sphere here, because a sphere, it's gonna give me what I want. I'm gonna unlock this, and this is my sphere. I'm gonna go for a polygon mesh sphere. Have more divisions. Make it, shape it to kind of the shape I want for this crater. We can even maybe deform this so the crater is not totally round. Not as much, but we can do something like that to make it. If you are not catching what I'm saying or don't understand what I'm gonna do with this, you will in a second. So I'm gonna put this under, and when I erase it, it's gonna erase these parts there. Those pieces there are gonna be lift up with this geometry, and they are gonna be forming like a crater shape there. So that's gonna be it. That's my geometry. So now I'm gonna animate this. It's actually gonna be animated. I think that's gonna be my position, my ending position. And just think about this. This explodes. Maybe I want this at frame 3 to already be there. Frame 1 is no simulation, 2 is the start, 2, 3, 4. Let's do it at 4. Let's add a new transform here for the animation. And I'm gonna call this anim in colored green. Don't forget your workflow. Get a workflow and stick to it. So I'm gonna add a keyframe at 4 and at 2. I'm gonna pull it down to where it's not colliding with the object at all. Needed to pull it a little bit more. So let's go down at frame 1. Let's do this as at frame 1. There, it's just under the, and I don't want this to be a Bezier curve. I want a linear curve, and this is what's gonna happen. It's gonna explode, and those pieces are gonna raise, and that thing is gonna be up, 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 like that. Yeah, I think that works. I like that. So let's see how this works with the simulation. So we're gonna make this also color it blue because it's gonna be part of the simulation. So let's go to wire, solid view. Let's make this an RVD object. Yeah, an RVD object. And what else do I have to do with this? Go to the top here and use the deforming geometry, because if we don't use the deforming geometry, it's not gonna go up. Let's hide this sphere there, the magnet metable. So now what's happening? Yeah, I don't think this is working. Is it? Alright, so I think something worked. No, it's not colliding with that. So this actually needs to be not an active object. I need to put it, yeah, let's see. Yeah, I don't need to make this an active, just remove the active object thing. So it's just using the animation. Yeah, there we go. It's moving those pieces. So let's see how that looks. Now you can see this is kind of erupting from below, and yeah, that is looking pretty cool. So now you understand what's happening here. It's raising those pieces, and we're actually not gonna see that. It's just gonna be like that. But you can see that simulating the underside of that explosion there, and you can see these pieces that we have these smaller puddles of smaller pieces look pretty cool with that simulation there. We can hide the ground plane so we can see better that and hide that. So these chunks look pretty cool and give it a lot of form to the simulation. A lot of dynamic, lot of dynamism. You can see from here, you can start to see where that puddle or that explosion raised all those parts up, and that is not gonna go back down because that sphere is staying in that place and they're colliding with that, so those pieces are gonna stay there, just resting on top of that. So you can see that this is looking pretty damn cool so far. There you go. Look at that. That looks pretty cool. Some pieces actually jump and bounce and stuff. That's pretty cool. And if we hide the wireframe, yeah, that looks pretty damn cool. Alright, so one thing here that we're gonna do, yeah, I like that a lot. I like it better than my old one. Yep, pretty damn cool. So one other thing we're gonna do here is just see what is the area that is actually colliding. You can see this is the area that we want generally, but you can see all of these pieces over here are kind of moving and shifting a little bit, even those pieces here. And for integrating this into a shot, we need to have like a somewhere to mix this with the real shot. So if these pieces are actually moving, it's gonna be more problematic to integrate. So instead of trying to get these pieces not to move, you can see one piece is actually going off there. We're gonna make those pieces inactive. All those pieces on the outside, we're gonna just mark them as non-active. So those are not actually gonna be moving at all. And how we're gonna do that with the new pack primitives, you can just make it pretty cool. We're gonna go here, and since this it's different than the old RBD objects, you can see we have just one object for the whole thing instead of one object for each piece. If we had that, we'd had like, let's see how much objects is in this guy. Does it say? Like, I think it's 1070 primitives. That should be the number of objects of packed primitives here. If we had one for each here, it will be a lot more slower, and I had to be stopping and pausing the video each time we wanted to see something. So this pack primitives actually kind of works very similar to particles. If you go here to ground and the geometry tab, you can see there's all this. Each one of these rows is one of these pieces, and each one has attributes like active, which is the one that we're gonna modify. A position. They have the some bullet solver data, the mass, if they're computing the mass or not, the density, all of those, and all those attributes you can just set yourself. They have the name property there. All these attributes, you can see the whole list here. You can set these attributes, you can control them, and the best way I found to do this is actually using a subsolver. Works pretty cool. And that's because, as I'm saying, this works very similar to particles. I think you can even use particle forces to control these guys. Um, I've done some experimentation with that, and it works. So because it's just kind of saying that each one of these pieces has a point that is actually that piece. You can see like the points we created for scattering this is actually being considered as the whole piece. So let's go and create here in the leave the details view on there, on view there, and here we're going to create a multiple solver. We're going to connect this, and we're going to remove the rigid solver from there, put the multi-solver there, put the rigid body solver there, but we need a sub-solver. And we're going to put the pop solver, the sub-solver first. So we set the properties first, and then it calculates this. I'm just going to name these to active objects. And to make this easier, I'm going to go to the ground object, and I'm not going to create active objects. and I'm just gonna set the objects that I want active in this guy. So you can see now if we go, we just hide everything and just show the active property, you can see now everybody is off. If I hit play, nobody's gonna move now. There's no movement because no objects are being created as active objects. So to create just this area, we're gonna add that attribute here. Let's go inside there, double click that, and in the dot geometry node that we have here, we have a few nodes, but we're gonna use the dot geometry node. We're gonna create a group. We're gonna create a group to define an area. Let's call this active area group, and disable the first one. We don't want to do it by name. We want to do it by bounding. Enable the bounding and create a bounding sphere. Now if we click this to see the sphere, you can see there's the sphere. Hope you can see that. If I make this bigger, I'm gonna take it to the area that I actually want to be this to affect this to this. So this is gonna be defining the primitives that I'm gonna do that are gonna become active and are actually gonna be part of the simulation. So I have that whole area, and you can maybe add a delete node to visualize that better and delete everything on that area, but as primitives, as points. Just remember that to consider these points, because pack primitives are, if you delete one point of that primitive, it's going to delete the whole primitive. It's just consider this as points all the time. I don't think that this is our primitive, so I changed the grouping to points and I'm deleting points, or maybe not delete the points. So I have all that area is the one that I'm gonna delete, like that. That's the area that I'm gonna become make active objects of, and I can tweak this till I'm happy. I don't want this to go all the way to the edges, but I do want to have a little bit of padding so the objects can move. I think that's enough. I have a border that is not gonna be moving at all. So, and actually I can move this over here because that was not in the center. Alright, I like that. So I'm not gonna delete this, that was just a visualization thing. I guess I should be using the visibility node for that, not the delete SOP. There you go, that's what's happening there. Those are the pieces that are gonna be static, and these are the pieces that are gonna be moving. So let's just disable that guy. And now to add the attribute, we're going to use an attribute wrangle node, which is a very cool node. Let's name the to active, so we know what this is setting. And we're just gonna set this for the active group, the active area, but this is gonna be so easy to do. It's just gonna say integer, or just grab the attribute active and set it to 1. And if you haven't used this attribute wrangle, these wrangle SOPs, they are so cool. You need to start using them. And what you type here is a Bex expression, which is really cool. Okay, I just duplicated that, and it's pretty cool to do this using Bex, because this is very efficient and it's very calculated, very fast. I won't say as fast as C code, but sometimes they side effects says that might even be faster sometimes, or as fast as C. So there you go. That's a very good reason to use it. So what I'm doing this is just saying with the add symbol, I'm grabbing an attribute, which is this attribute that the pieces already have. And I'm grabbing the attribute I'm grabbing is the active attribute, and I'm setting that to 1. You can see here in the properties, all the attributes are back to 1. If I go here, all the active attributes, hide all, are back to 0. And here, in this node, they're back to 1. But I don't want to set it for everyone, so I'll just filter that group. And now I have some pieces that are active and some that aren't. You can see those are active, and let's see if we can find a place with some active, some don't. So it's just giving the attribute for those pieces that we defined. So now if we go back here, of course save, and click play, now you can see this is working. And I actually think it should be faster because it's not calculating as much pieces as before. I haven't done any tests, but it should be faster. You can see if we go back to camera view, all those pieces are moving, and none of the outside pieces are going to be moving at all because they are not active objects. Let's play again. You can see those pieces are moving. The ones that we want to move in the edges, no one's going to be moving. We have that secured. So that is pretty cool way to just solve this issue. Alright, let me just give me more of a simulation frame so we can see that. Cool. I guess that's enough. Cool, you can see that looks pretty damn cool. Pretty cool. There you go. Let's simulate up to frame 50 so we can just see what we're doing. Alright, so next what we're going to do is fix this area here at the edges, because we don't want these pieces to be falling under the floor when we have when we put this into our scene. You can see this is looking pretty good. I like that a lot. Pretty cool. Our pieces are behaving way better than my pieces. I think between the time that I did mine and this, Houdini, Side Effects fixed a few issues with the bullet solver, and now actually the pieces are behaving way better than they were behaving in my the version I was doing. You can see the pieces rolling from here, those pieces rolling down here. Like, it looks pretty amazing actually. Pretty cool. This is pretty damn cool. And it's just thanks to how we plan this, how we focus the detail on where we wanted. Thanks to that, we knew what we wanted to happen with the next level of detail here, raising those pieces there. So I guess this guy is almost ready. So we're gonna cache this now. Yeah, we're gonna cache this. No, I said that we're gonna fix the edges, right? We need to fix that. So let's go to the ground and expand from this grid. Transform. From this grid, we're gonna create kind of the negative space from this grid, so I'm not gonna transform this. I should create just a null. Up, come on, just delete this. And what I'm gonna do is just select the outer edges. Loop. Do I have the edges? Nope, I didn't. Loop that. Alright, I have all the edges. I just selected one. Press L for loop. And now I'm gonna extrude that. Poly extrude those edges. Yeah, well, I have them selected. Thank you very much. Poly extrude those in like this, but make this just the normals, the average positions. Come on, make me happy. It's okay, don't use scale, just transform those and then just switch to the transform tool and scale that with the come on, what are you doing? Not working. Okay, so you don't want to work, huh? Let's see, globally, scale that globally. All right, that's what I wanted to do. Okay, but that is actually looking pretty bad. Do I want that to happen? Yeah, okay, I want that to happen. All right. So what I'm gonna do with these guys in the center, I'm just gonna delete those guys here. Just gonna make a hole. Or just here from the don't output this, the back of that, just the sides. Nah, doesn't remove that. So I'm just gonna select these guys and delete them. So I have a hole there. I don't have a hole. What the hell's happening? Is it something that it's been... The hell is happening here? I want you to die. S4. Have that there. I don't want it. There we go. I want a hole there. That's it. That's what I want. I'm just gonna divide this a few times. So I just use a divide. Not that, but bigger polygons. Maybe a bit bigger. Something like that. That looks okay. Let's go see through the camera. Alright, that's more than enough. Maybe in this direction we need a little bit more. We may want to scale a little bit more in that direction. So let's just grab the points on the sides. These guys here. Home those. And scale it like this. Just view it from the shot camera. If you don't like this geometry, just model your own and do it as you like. Alright, I think that's enough. If I see the image, it's going all the way here. Yeah. Alright. So maybe we can just go and create some geometry for this part here now that I seen this. Geometry for this, geometry for this, maybe even geometry for those buildings at the back. Let's continue doing that here since we have this piece here. Let's just poly extrude this down. So we have this as something solid. Hide this guy for now. Poly extrude. globally down by 0.1. No, negative 0.1. There we go. We have it going down, and we need the output the back. Use the normals. So that is that. Go to the camera. We need to create a tube for this guy. So we go there. Let's see. Let's make this tube slimmer. I'm just trying to find the base of this, but the height. Just copy the height, paste it here. Relative channel reference doesn't need to be like that. Just try to find it in the scene. See where it is. Eyeball it. I think that's a good place for it. Is it? Yeah, I think that's it. I think that's gonna be my lamp post there. And I'm gonna put it under the ground a little bit because I'm gonna create a piece for this. Let's create a box. And see that. Let's go to the perspective view to put this in place. Again, go to the camera, make this smaller. Just don't move them like pretty bad. So now I do want the center copy parameter to be on top of the floor. So we're gonna try to match this edge with the edge of the box. So there we go. That's the box matching there, kind of there. Make it wider. I think that's matching that well enough, but it's kind of rotated. So let's just start modifying the points. So gonna move it back so it kind of matches this profile. Gonna move this back to make this the back side, but I'm gonna move this out of frame, and now I'm gonna split this a few times and center the midpoint there, 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 a few times here. And you can see it's actually not in the right place, or maybe this tube is not in the right place. Move that over there. This lamppost is not. I trust the box to be better positioned than the post because it's matching the image here. So why is this creating this weird network over here? Put it here. So now that we have more points, let's just start giving this better shape. See, we're matching better with the floor, so I trust that this is closer to the actual image. And right now I'm just looking at the bottom part. It's kind of maybe higher than that it should be, but I'm gonna modify it when I'm done with this first shape. I think these guys are too much in front. Alright, so I'll just modify the top part. Select all the vertices on the top, and let's go to a shot camera and see how tall this should be. Kind of like that. So now these points are not far away enough. So let's move these guys back. There we go. There we go. Nope. Select the right points. Again. Add selection. There we go. Now this is not working. So that's kind of following the profile there. Now I'm gonna move this back a little bit. So I'm just gonna approximate this to have a few collisions there and stuff, but it's not really important to have it super mega extremely exact. If you want to have that super mega exact, well, just tweak it more. And I want to just move these back points here, and you can see that kind of looks like what we're looking in the image. That kind of looks like that. All right, I think that's enough for that area, and we can merge all these guys, this geometry that we created for the floor, this geometry we created for the post on that side, and I'm just gonna create maybe one box for this building, one box for this building, maybe. In mine I didn't, and I got some pieces looking funky over there, so we could try to do that. Just make another box, which we have one here. It's already set up to be on the floor, so we can use this one maybe. Just make sure you're moving that one. So let's make this taller and wider. See if we are in the right place. You can see this camera is actually very close to what we have in the scene. We're getting really nice perspective there. Alright, I think I'm gonna align this with the corner, move it in C, Z, depending on what part of the wall you are. I'm gonna just align it with the corner of the building and make it taller, and make it wider. There we go. That is cool. Let's create another one for the other building. You can see that's pretty close to the actual camera. We're getting very good perspective. Although this is kind of going up, we're not gonna use that. So there we go. We're gonna go here and add that, here and add that to the final collision meshes, and this is what we have for collisions. You can see this looks pretty close to that scene. You know, there's buildings, street, the lamppost, the little sidewalk piece there. So this is gonna be out. Just create a null. Come on, save, of course. Create a null. Call this collision geo. Collision geometry. But we are in the ground object, so we're not gonna display that. We're gonna display this. So let's move that into a new object. Scene collisions. Let's call that scene collisions. And here an object merge again, and into this object, and use the scene, the ground collisions geo. There we go. And make that a static object. There we go. And check your static object in your DOP network. Sync collisions, see that? There we go. Don't display the geometry, show collisions, and that looks horrible. So why? Because creating a whole tetra, a whole convex hull of the over all that stuff do you want? What we want is what you want to create one convex hull for each. So just click this toggle and there we go. That's our collision geometry now. Creates a one convex hull for each geometry, and it's actually that hole here that actually just went away. I don't know why we did that. That was a stupid move on my part. Didn't thought about the convex hull before. So anyway, it's not gonna matter because we have a ground plane that it's in the same place. So doesn't matter, but it's something that I should have considered before making that stupid hole there. Alright, so now we have this. I don't want to see this collisions geometry, but let's just click play. We'll see what's happening. Alright, that it's calculating. So I'm gonna let this calculate, and I'll be back when it's done so we can review it, and then we're gonna be caching this. Alright, so this is simulated, and this is what we have. And I don't think I think that this time pieces didn't collide with the post or anything, but I think one of mine actually they did collide, and but you can see they're going up on this. They're not going under the floor now. They're staying, of course, on top of it. Some might be going all the way here, and there you go. That's one that's actually colliding with this building. There's a lot of pieces, that small pieces that go way over there. So I think this is looking pretty good, pretty cool. Actually, one piece is actually going towards the post and stays there. So now that we are happy with this, I'm more than happy with this. This looks pretty good. We're gonna start just caching this to disk. Since this is good, let's go to the ground plane. The ground. Just have this guy. I don't want to see that. This is our cached into RAM geometry, but we want to cache it to disk. So again, a ROP output driver like we did for the car. Why is that not showing? What happened? There we go. Alright. So we're gonna simulate up to, I don't know, let's see up to what frame we need to simulate. Maybe more frames. I don't think more than 70, but I don't see those pieces stop moving, so I think we're gonna have to simulate more than 70 frames. Alright, so let's just put it up to 120, which is gonna be the total length of our scene, so we don't have any pieces being cut in the middle of the movement. So go to my folder, create a ground, same folder, create a ground same version 1 folder, copy that, use it as the name, Russian file for BGO and Andy. Gonna click save. I'm gonna do a save, and I'm gonna just simulate this and render at the same time. So I'm gonna see you when this is done rendering. So there we go. The first frame is gonna be fast because they're already in RAM, but a few are gonna take more time. So alright, so this is done simulating. Let's just go to file to load this guy back up into the scene. Relative reference. Color these guys like that. Like that. Like that. Now I'm just seeing the simulator result there. That looks pretty damn cool. What we can do now, and what we need to do actually now, it's set this in time, because right now it's not in time. You can see it starts breaking at frame 1. So we need to do the same thing we did with the car. Oh, let's hide all the scene collisions. That ground plane, we need to see that. Go here and use again a time shift, and we're gonna shift this by 14 frames again and make this to say no geometry when it's missing. But if we, let me just see, there's the missile. Set in time. Let's hide that shape there. We can show the low resolution car and make a preview of this, see if we are actually in time. But the first frames, there's no floor, there's no ground, so we can do a few things like I can have another file swap just with one frame. Just load frame 1, which is static. Just make a shift switch. Shift switch. So up to frame 13, I show the static one, and at frame 14, in this case 15, I show the other one. I'll just change that keyframe to 14. 14 is the static, and then 15 is when it starts to explode. So let's do with flat shaded. Let's do a preview. Let's see if this is actually looking on time. Overlay there. Let's do a flipbook, and the flipbook's gonna be pretty fast. Doesn't take that much time to do it. A few seconds now. Alright, I can see that's looking really good. So let's now play this. Yeah, that looks on time. That looks okay. Looks pretty good to me. And on top of this, gonna be the pyro explosion and some smoke that we're gonna do, and we need to do the exhaust fire of the missile and stuff. And I think this is gonna be done in volume 2, because this is becoming a larger tutorial than I thought. There's a lot of information to cover here, so uh, this is it for this part. uh, I hope you learn a lot of stuff. I know it might be a lot of information to take in, but as this is a video tutorial, you can see it as much as you need, and just take into consideration the details that you want to see in your result, and the process becomes way easier. So alright guys, thank you for watching this, and I'm gonna see you in part 2 of this. Thank you.